Hello, everyone. Has anyone here not heard about autonomous cars at all? No, right? That's a ridiculous question in 2018. Autonomous cars are becoming more and more popular by the day. And as that continues to happen, autonomous RC car testbeds are becoming more popular in university research labs. However, despite this increase in popularity, there are only a small number of open source autonomous RC car testbeds out there. And even those, they usually lack neither the quality or the quantity of their sensors. And that's exactly where we come in. My name is Layman Sofawi. I'm the team leader and part of the software team for the UTDesign autonomous cars fleet. These are my teammates, Steven and Omar on the software team, Jocelyn, Abulash, and Ridwanullah on the hardware team. And our goal from this project is to provide an RC car autonomous testbed that can be used to test out a variety of control, optimization, and machine learning algorithms. As you can see in the picture, we started off with a basic design with a front-facing stereo camera, an IMU, inertial measurement unit, and a LiDAR, which is like a radar, but with lasers. From there, we also added a Jetson TX2 processor board. This is kind of a typical design for most of the other high-end autonomous RC car platforms. So we started analyzing how we could improve this. We noticed that the sensors equipped don't work really well for close-range detection. So our hardware team started working on a microprocessor circuit that would incorporate ultrasonic sensors for close-range detection. They'll also be including wheel encoders to estimate the velocity of the car in real time. In addition to that, we're working on adding 3 additional monocular cameras that will help provide the car with 360 vision. And to further distinguish our platform, we plan to add a 4G router and a GPS to enable outdoor navigation. So far, we have assembled the car with the 3 basic sensors, and we've created the electronic speed controller. Our software team has been working on combining the different SDKs, drivers, and software packages required to operate the different sensors and actuators. At this point, we have the ability to read the sensor data. As you can see in the LiDAR visualization image, we can also issue steering and throttle commands to the motors. For next semester, we plan to finalize our design, document the hardware and software aspects of our project, and demonstrate the capability of our platform by performing a sample autonomous driving task. This is our approach towards an autonomous RC car platform. Thank you very much. Any questions?
Cars today are getting a lot more autonomous, obviously, and just recently purchased one that does the cruise control on its own.
Yes.
Which was interesting when I didn't know it when it did it. But kept wondering why did it slow down when I got behind the car. But anyway, the other thing too, I also know that BMW is working on autonomous cars too. And that's where their intent was to have a car that would take you to work. You tell it, come back and get me at 3 o'clock. It would go off somewhere, park itself, and then come back. With that in mind, how autonomous would this thing be that you're working on?
That's a great question. So we are aware that many of these major tech companies and automobile companies are working on autonomous driving cars, such as Tesla, BMW, and even Google and Apple are trying to get in that market. However, this project is kind of different than what you'll see outdoors. This is going to be a test bed, in particular for research environments. So when PhD students have control, optimization, or machine learning algorithms that they want to test out, that's what they would go to. We're trying to add as many sensors and get as much redundancy as we can get so that you would be able to test out whatever you would want to the extent that we can fit in this car. So it's a different market. It will also be open source.
Yeah, as soon as I thought about that too, everybody saw the movie where they had the Johnny cabs, where you could, you could just talk to the cab and it would go and do whatever you wanted it to. I don't know how a lot of people may accept that, not being in control of a car. I never will be, but that's okay.
So at this point, we're just providing the test bed that users can use to make as autonomous as they want. The sky's their limit, but In our case, we're just providing the functionality of being able to control the steering, the speed, getting sensor data, and all of that stuff. We will be demonstrating that you can use these stuff through a sample autonomous driving feature that we will implement in Senior Design 2. However, we haven't chosen that yet. It could be anywhere from hallway navigation to just using images to classify objects into people or signs or that thing. And that's something for next semester to decide.
It's more a research and development.
Yes, yes.
It's a platform.
Yes, it's a platform for research.
Yeah.
So on your remote controlled vehicle, I've had some before, and the steering was like all the way to the left or all the way to the right or
Okay.
straight.
Yeah.
Does yours have,
So-
is it analog or digital in the sense of steering? And same with the
Yeah.
throttle, is it on off or is there a?
Yeah, so
continuous-
there's a range. You can go from a certain zero angle, maybe 30 degrees right or left, or something like that. So there is, it's more discretized than just full on right or full on left. You can choose somewhere in between to whatever degree of or precision that the servo motor can handle, because there's a single servo motor that controls the steering, and you can always program that through a PWM signal to provide whatever angle you want. So it's kind of analog in that sense.
Good.
Okay, let's thank the team.